Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Today, I'm going to be reviewing the topic of finding the volume with known cross-sections, specifically cross-sections that are triangles or semicircles. In order to find the volume, we have to use definite integrals. For cross-sections that are perpendicular to the x-axis, we use the basic integral from a to b of a of x. A of x represents the area of a solid, which can also be known as S or S of x, and we'll get into how to find the area in just a bit. For finding the volume of cross-sections perpendicular to the y-axis, we'll be using a very similar integral. However, there are two main differences when the cross-sections are perpendicular to the y-axis. One, we have to get the equations in terms of x to find the area. Secondly, the limits are not going to be on the left and right of the solid or the x-axis. They will be on the y-axis, or the top and bottom of the solid. This top part just reviews what we talked about, but I want to talk about how we find a of x, or s of x, which is the area of the solid that is formed by the two functions. In order to find the area of a solid with cross-sections that are perpendicular to the x-axis, we have to take the top function and minus the bottom function, and that represents s. If the cross-sections are perpendicular to the y-axis, we take the right function minus the left function, and that will represent s for us, or the area. Once we find s of x and the limits, we can plug it into the right integral to find the volume. For triangles and semicircles, there are 4 different equations to use to find the volume. From looking at all these equations, we can see that they are pretty much the same. You have the integral from a to b of s of x squared, d of x, or d of y. The differences are the constants in front of the integrals. When the cross-sections are right isosceles triangles with the leg across the base, we multiply the integral by 1/2. For right isosceles triangles with a hypotenuse across the base, we multiply the integral by 1/4. For equilateral triangles, it's the square root of 3/4, and for semicircles, you multiply the integral by pi/8. So now that we've reviewed how to find the volume, we're going to go over a multiple choice question. The base of solid S is the region bounded by the ellipses 4x squared plus 9y squared equals 36. Cross-sections perpendicular to the y-axis are isosceles right triangles with a hypotenuse line across the base. Determine the exact volume of solid S. So for this problem, since the cross-sections are perpendicular to the y-axis, we have to write the equation in terms of x. If we do that, we end up getting 2 equations. The positive and negative square root of 9/4 times the quantity 4 minus y squared. Now we have to figure out which equation we have to use, which will be 1/4 times the integral from a to b of s of x squared d of x, or dy in our case. Now we have to find what s is. We have to take the equation on the right minus the equation on the left. The one on the right is the positive equation, and the one on the left is the negative equation we got. Now we just have to plug in the limits, which you can see here on the graph. Remember, we take the numbers on the y-axis rather than the x-axis for this one, which would be 2, or negative 2 here, and positive 2 here. Finally, we just have to plug all of this into the calculator using Math 9, and we get the answer 24. Now we're going to do an AP free response question. This one was taken from the 2014 test. Here we have 2 equations. F of x equals x to the 4th minus 2.3x to the 3rd plus 4, and y equals 4, which creates the figure we see to the right. For this question, we're only going to be doing B because it pertains to our topic. Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. So we know which equation we're going to be using. We just have to plug in the right stuff. To get s of x, we take the top function and subtract the bottom function. The top function is y equals 4, and the bottom one is f of x equals x to the fourth minus 2.3 x to the third plus 4. We can see the limits on the graph to the left, which are 0 and 4. So now we plug everything into the calculator and use Math 9 to find the volume, which will be 3.574. But what if we had cross-sections that were equilateral triangles or semicircles? We would find s of x and the limits the same way, but the only thing that has changed is the constant out front. For an equilateral triangle, we would multiply the integral by the square root of 3 over 4, and we'd get 3.095. If the cross-sections were semicircles, we'd instead multiply the integral by pi over 8, and we'd get the answer 2.807. Here are the scoring guidelines for this problem if you wanted to look. Other than that, this is the end of this review. Thanks for watching, and good luck on your AP test.